So moving on to like what you're currently working on, you mentioned earlier that you're working on a new router for React. So why another router? How is it different and what is it doing differently?
Great question. So yes, it's a new router. I honestly didn't want to have to build it in the beginning. At Nozzle, we have a lot of dashboards, and these dashboards are showing a lot of data, a lot of widgets. They're data exploration dashboards, and essentially every dashboard is like a function that just has a lot of widgets on the screen, and each one of those widgets has its own parameters and its own state. All of that needed to be stored in the URL, like every bit of it. And we looked into ways of taking the state and hashing it and putting it on the server and sharing links with, with IDs. And it's just a terrible experience to do it that way. It's so much better to leverage what's already there in the URL. So in the beginning, I just wanted to design this entire dashboarding experience so that all of the widget state and everything lived in the URL itself. And essentially, that meant taking this big JSON structure that represented the state of each dashboard and finding ways to reliably serialize it into the URL and bring it back out. And it wasn't that difficult to get my hands dirty in the beginning. I was using React Router v5, search params, and just kind of doing it in a really hacky way, right? Uh, and then I was like, oh, might as well try React Router v6 beta. So I was actually using the beta in Nozzle for a while. It was in beta for a long time. But then some problems quickly arose with that. The first one that was very apparent, even from v5, was that when I started moving everything over the TypeScript, a lot of my libraries were moving over. Things were getting better, but one thing that was kind of like lagging behind and stuck in the Stone Ages was the routing logic. And at first I was like, routing, like it's not that bad. You don't need to be super type safe. Then I was like, oh crap, all of my search parameters are coming out of the router. And that's driving a majority of my state now. And in fact, the more and more that I got into using the URL for state, which I think is really a really great pattern, and we should be doing it more. So much of my state was moving from use state into the URL. And honestly, if you think about TypeScript and types and state, like that's where all of your state comes out of usually. It's just like use state. Moving it into the URL is basically moving it into this new black box that I lost all my types and essentially had to start like, typecasting everything. And that just, it's terrible because it doesn't track through the entire system. And it's just hacky. And it kind of I started opening up this black box of like type safe URLs and type safe routing. And I started learning a lot. I started learning that like, the URL as a serialization destination acts a lot like an external asynchronous resource, as you would with any other external state. When you fetch it and you get it back, you kind of have to validate it because it's just coming from a JSON string. So similar to how people are like writing Zod schemas for, their CRUD, their CRUD fetches and fetch and GraphQL schemas and whatnot. The URL has exhibits those same features where you're essentially allowing users to input whatever the heck they want into this box on the screen. And you need to reliably parse it, validate it, set defaults, and at the same time type it so that you have a consistent and reliable interface coming out of it. That entire pipeline was just it's not that it wasn't built in, but it was even difficult to do in userland with React Router v6. I basically had wrapped every function, every export, everything that I could get out of React Router v6, I had wrapped and proxied until the point where I was just like, I've basically rewritten my own router just through this proxy layer. That's how React Location was born, which was my toy router. It wasn't type safe, but it was me kind of just getting a grasp on how to build a router. And finally, this new router is where I've tried to rewrite the routing experience from the ground up with types involved. And so that means that everything from route definitions, even the nested definition stuff, is all type safe. and the resulting types or the resulting routing structure that you get, it's fully typed. And then all of the APIs for consuming that routing structure need to be fully typed as well. Lots of different challenges in each of those different layers. And we can talk about those if you want. I think they're all interesting. But yeah, types were the biggest driver for this. Obviously, it wasn't too difficult and very obvious for me it was obvious for me to layer in things like data loaders and actions and layer in, nested routing is kind of just the new standard. So it was easy for me to take some of the best parts of React Router and Next and Wouter and just kind of put it all together and build the system that I wanted. And it's got support for Zod schemas, and it's a lot of fun, and it's a joy to use. So some of the features right out of the gate that I can tell you, like all of the paths are type safe. So it's basically impossible to write a link that isn't type safe. So if a page doesn't exist or a route doesn't exist, you'll get red squiggles for it. If it requires search params, you have to supply them. They have to be the right type. If you're writing links that are relative, like it knows about relative link navigation and where you are. It knows all the types know about your nested nature of your routes. So if you're in a deep component, you're not just getting routes or type information for the route you're in, but the parent, the entire routing structure is actually reduced as you go down the usage APIs. So you're, down here at the, level C, you've got type information for A going into B and going into C and kind of getting intelligently merged together so that you know of all of the search params and all of the loaders and all of the things that you have in that. And even in the definition files or the definitions themselves, you can define search parameters in a top level route and then have nested routes. And in the definition itself, it will know about the types that you have created in parent routes while you're in your definition, which is easier said than done. It's required some interesting API design and to get around this kind of stuff. But at the end of the day, it's what I needed, and so I'm actually still hooking it up into Nozzle. But what it means is that all these widgets and all these crazy things that I have on all these different dashboards, when you hover over a link, I know of a surety that it's going to a place that exists with search parameters that are exactly what they need to be, and that the URL that's produced is going to be exactly what the user wants to see, and they can share it and collaborate with it with teammates. And just day one of popping in a Nozzle, I found like just tons of bugs, just trying to pass search params that don't exist and passing numbers where they should be strings. So yeah,
must be a good feeling finding those bugs.
Good and sad, oh man, Tanner, you were an idiot. Why did you do that? But I don't blame myself too much. I didn't have TypeScript, so it's a lot of fun.
Yeah, it's fun.
So all of that type safety comes pretty easily from like the user standpoint. I saw in the docs you kind of do this like one cool trick to make the types available. I think what you do is like you declare your router, and then right below it you do like a TypeScript declare and then declare an import, and that like kind of just makes everything work, right?
Yeah, because without that you would have to provide an API layer that consumes the router everywhere that you use it, which is still possible if you for some reason can't do it the way that we want. So instead of doing that, you're right. So we use something that's kind of an interesting hack in TypeScript. Not really a hack, but it's just an interesting pattern. It uses declaration merging, but what we do is we export an empty interface called a register. And we export that interface. Actually, we're doing it across almost all of the libraries now. There's just a register interface. And what you can do is you can declare that interface, and then under specific keys for different libraries, like so in router, it's the router key. So you declare the router key, and then you pass type of your router. And what that does is it registers because interfaces are mutable, it registers the type of your router into the inner type space of like the entire module. And what that means is that now when you go to consume exports right out of the library, like use, route, or link, or something like that, we can actually just reference a special type inside of the library called registered router. And registered router is it's a conditional type that says, hey, if registered dot router extends a router, use that. And if it doesn't, then just use kind of the default router type. And that way you can provide type safety to the rest, like to all of your top level exports, without ever having to necessarily import your router everywhere you go. It's pretty great.
Yeah, super cool pattern.
We're actually using it in React Query now in the next version. So you're going to be able to, you can actually set the default error type so that if across your entire system, you know that you're only, you want Axios errors or something, you can actually register the error type and pass Axios error. And that will set the default generic across the entire library to be that. So there's a lot of cool use cases for it, for setting type defaults without being forced to use APIs that rely on scripted composition, to get that kind of default.
That's awesome.